All right, party people. This week is going to be the last week of new stuff. It has been asked that we do not assign anything new next week so that you guys can get caught up and get all the work in because our grades are going to be due the following week. So they want to just make sure that we get everything done. So I'm going to post this video, which is going to go over the 4 operations when combining polynomials. Probably tomorrow, I'm going to be posting how we're going to be doing the grades. It's going to be something along the lines of if you are missing no more than 2 assignments, you're going to get an A. If you're missing no more than 5 assignments, B, etc. And then we'll discuss if maybe you fall in the C range and you don't want the C, then you can opt in for just a pass. Or if you're happy with the C because it makes your GPA go up, then we'll keep the C. So we'll talk about that later. But anyway, polynomials. Now, you guys have worked with polynomials. If we break this down into 2 things, poly and nomials, this means poly is many, and nomials is derives from terms. So we have many terms. So something like 3x squared plus 4x minus 1 is actually called a trinomial because there are 3 terms to it. But since there's still many terms, we call this a polynomial, but specifically it'd be a quadratic trinomial. Over here we have a cubic trinomial, but both of these are considered polynomials. So we're going to start off with adding and subtracting, and as you can already see, it's super easy. You're combining like terms. So addition and subtraction follows the same rules. All you do is just combine like terms. So the first thing that I did is I distributed this negative to every single term. So instead of a positive 4x cubed, it's a negative 4x cubed. Instead of a negative x, it's a positive x. Instead of a positive 6, it's a negative 6. Then from there, I combined like terms, and I started with the highest degree. That always goes first, and then it goes in descending order. So negative 4x cubed was first, 3x squared was next. I combined the 4x and the x to get 5x, and then I combined the negative 6 and the negative 1 to get negative 7. Now what I have here is a cubic polynomial. Yay! Multiplication. Now multiplication, you can have any number of terms, so you can see is the more terms you have, the more distributed property you're going to have to do, thus more difficult. But I'm going to keep this relatively simple. I'm not going to give you anything too backbreaking. So this one here was a quadratic trinomial times a cubic binomial. And so I first distributed the x squared to the x cubed and the x squared to the 2. So I'm getting x squared times x cubed is x to the 5th, and x squared times 2 is 2x squared. Now if you're thinking to yourself, how did I get this? Hopefully you remember from last year when you talked about your exponential properties, when multiplying like bases, so x and x, you simply add the exponents together. Now, why do you do that? I'm glad you asked. So over here, I have x squared and x cubed. X squared is x times x. X cubed is x times x times x. Well, if I do x times x times x times x times x, I have 1, 2, 3, 4, 5 x's, or x to the 5th. The whole adding exponents is just a shortcut. So if you're ever confused, write it out in an expanded form, and then just simply count how many like bases you have. If we want to complicate this a little bit, we could have x to the 4th y cubed times x squared times y. Well, what would this be? Well, if I just expand it out, I have 1, 2, 3, 4 x's. I have 2 more x's. I have 1, 2, 3 y's. And I have 1 more y. So what does this all equal? 1, 2, 3, 4, 5, 6. X to the 6th, 1, 2, 3, 4, y to the 4th. Or 4 plus 2 is 6, and 3 plus 1 is 4. So there's a little recap of exponential properties. We would have spent probably an entire day on that. You just did it in about 30 seconds. Yay! Okay, so now that I distribute, I'm now going to take this 3x, that goes to the x cubed. So again, I have 3 x's here and 1 x there, so that becomes 3x to the 4th. And then 3x times 2 is 6x. Negative 1 times x cubed is negative x cubed, and negative 1 times 2 is negative 2. Now, back to adding and subtracting, like terms, x to the 5th comes first, 3x to the 4th comes next, negative x cubed comes third, 2x squared comes after that, 6x, and negative 2. I didn't have any like terms, so I didn't have to worry about simplifying them. And here I have a, a quintic polynomial. I had to go in my head. So it goes monomial, binomial, trinomial, polynomial, and then we also have linear, quadratic, cubic, quartic, quintic, sextic, etc. Yay. So that's adding, subtracting, and multiplying. Now on to the challenging one. Division. So if I had 3x squared plus 4x minus 1 divided by x plus 2, I have to use long division. Well, that's exciting. Now, just in case you forgot how to do long division, I'm here to help you. So I'm going to do 54,361 divided by 9. So just to recap the process of long division, we take a look at this 9, and we first pair it up with the 5. Now 9 doesn't go into 5, so I move on to the next digit. I now have 54. 9 goes into 54 6 times. So I'm going to do a 6 up here, and then I write the 54 beneath it. I subtract. I get 0. Next, I bring down the 3. 9 goes into 3 0 times, so I have to put in a placeholder. And then I can bring down the 6. And then 9 goes into 36 4 times. And so I write the 36, subtract, I get 0. Bring down the 1. 9 goes into 1 0 times. And now I'm not going to do a decimal, because maybe what you'll realize is that if I do this out, I'm going to get 0.11111 repeating. I don't want to do that. Instead, I'm going to take what's remained, what has been remained, what's the remainder, and I'm going to put it as a fraction. So the answer to this problem is going to be a mixed number of 6,040 and 1/9. This is how our answer is going to look. We're going to have our dividend, our divisors, our quotients, and then we're going to have our remainder as a fraction. So now let's go back to this example using this process. Well, the first thing I did is I'm going to take a look at this, and I am only going to use the first term, the leading term. Now what I have here is a binomial. So I had a single digit number, so I looked at single digits. I have a two-termed quantity, so I'm going to look at the first two terms. Now the first thing I'm going to do is figure out x times what will give me 3x squared, because that's what I did over here. I decided that 9 times 6 was 54. So let's try it out. X times what gives me 3x squared. So off to the side, I want it to equal 3x squared, and currently I have x. So x times what gives me 3x squared? Well, I need to have a 3, and I need another x. So I have to multiply x by 3x to get 3x squared. So I am going to write the 3x, and I'm going to write it above the second term. Over here, I wrote the 6 above the second digit, because it shows that I was using 54, not 5, not 4, not 543, but 54. Here, I'm using 3x squared minus 4x. All right, so now that I know that I have to multiply by 3x, I'm going to go ahead and do that, and I'm going to write that binomial under here, and then I'm going to subtract. So 3x times x is 3x squared, and 3x times 2 gives me 6x. And so now when I subtract, I have to make sure I distribute the negative. This is the biggest mistake that people make. They forget to subtract that second term. So 3x squared minus 3x squared is 0x squared, and 4 take away 6 is negative 2x. Much like over here where I brought down the next digit, I'm going to bring down the next term. And now we restart the process. X times what gives me negative 2x? Well, I don't need to multiply by another x, but I do need that coefficient, so I'm going to multiply by negative 2. And so I have negative 2 times x is negative 2x, and negative 2 times positive 2 is a negative 4. And then I subtract. So when I subtract, this becomes a positive 2x, that becomes a positive 4. And now negative 2 plus 2 is 0, and 1 plus 4 is 3. So now I'm at the point where I was here, where I now have a remainder. So I'm going to go over, and I am going to write 3 over x plus 2. Now, it's assumed, but I want you to go ahead and put a plus sign in there because you're adding this part to this binomial. Over here, we're just working with one term as a constant, so you don't need that plus sign because it translates to the same thing. But over here, you do need that sign. So the answer would be to this problem, 3x minus 2 plus 3 over x plus 2. So that's dividing polynomials using long division. Now I'm going to attach to this assignment 3 problems, an addition or subtraction, a multiplication, and a division problem. This is all the stuff that I planned on doing all week. But what I'm noticing is that some people are waiting until Thursday or Friday to post everything anyway, and then all of a sudden I'm getting flooded with 3 or 4 assignments from 12 to 15 people. And I'm getting that in stats and through Algebra 2. Remember, I have 77 students. And so now over the weekend, I now have a bunch of work to grade. Grade books aren't updated. So I'm going to try to do for the last week, just one assignment. It's due at the end of the week. Get it done when you'd like. I'll give feedback when I can. And I'll stay in touch about the whole grading thing and what we'll be doing next week. I also sent you guys out a little message about a survey I want you guys to fill out. It's for my master's class. It's super quick and easy, really not labor intensive. I just need it to collect data so I can state whether or not you feel having graded homework was more beneficial than not having graded homework. Anyway, I'd really appreciate if you guys fill that out when I send it out. Just have to get that consent form in. Anyway, good luck. Reach out if you have any questions.